All right, so let's take a look at the problem we're looking at. So we have an object of volume 6,000 cubic centimeters. So the volume of the object is 6,000 cubic centimeters. But very importantly, only half of it is submerged. Just keep that in mind. And it's inside a fluid of density 1.2 gram per cubic centimeter. So now the density of the fluid it's in is 1.2 grams per cm cube. Find the value of the buoyant force. Now, first of all, let's understand Archimedes' principle. The buoyant force is that force that's going to be opposing this object that's trying to sink by nature. So the buoyant force is going to be acting upwards in an opposite direction. Okay? Now, what Archimedes is saying is that the volume of the fluid displaced is equal to the volume of the object. Okay? So if we have the volume of the object that is submerged into the fluid, we can then use that same value as the volume of the fluid displaced. Now, the volume of this object is 6,000, but it is not all submerged. The volume of the object submerged is half of that. Hence, the volume of the fluid displaced is going to be 1/2 of 6,000, which is going to be 3,000 cm cube. Now, the buoyant force is going to be the weight of the fluid displaced. And the weight of the fluid displaced is going to be the mass of the fluid multiplied by the acceleration due to gravity. So how do we go about doing that? Well, we can find the mass because we know that the density is equal to the mass over the volume. We can rearrange this formula and find the mass because we already have the density and we have the volume. So once you do that, you're going to get that the mass is equal to 3.6 kgs. Now you want to pause the video right here if you did not get this answer. Now let's go back a little bit. You're going to rearrange this formula. And when you do, you're going to get a formula for mass. Mass is equal to so and so. When you get your answer, it's going to be in grams because you're working at gram per cm cube and you're working at cm cube. But when we find m to apply into the weight equation, it needs to be in kilograms. So you're going to get 3.6, the mass, multiplied by 10 or 9.8 for the acceleration due to gravity. And that's going to be 36 newtons. The buoyant force is 36 newtons.